Hi, my name is Charlie, aka the Guitar Boy. Uh, if you are there, you are right there, you are saying science is too difficult, chemistry is difficult, physics is difficult, mathematics is difficult. Come here now, this class is for you. And if you are in Benin, if you are in Edo State, Benin City, Saple Road at Bypass, if you want physical class, you can come to our lecture house at Saple Road. We are close to Belisima Junction. If you stay from Saple Road, around Saple Road, so you can come and learn, so that you can ask question about those things that seems to be difficult for you to understand. You can ask. We have qualified and professional teachers here to explain those things to you. So that's for that. Today we are going to be talking about a particular topic in mathematics that most students really dread a lot. Sometimes it's not because this topic is difficult, it is because of the approach the students are taking. That is why they find it difficult, because there are something you must know, you should know before you approach geometry. So the topic is what? Geometry. We are just going to talk about introduce the topic today. Meanwhile, in our subsequent class, I will just divide I will just talk about other parts about this topic and solve examples on this topic. Now today I just want to let you know what you are expected to know first before even attempting geometry. Because if you don't know this, don't just go there. You won't understand. You won't be able to solve any problem in geometry. Now, to start with, what is geometry? Geometry is a branch of mathematics that deals with the study of shape, size, and position of an object. The branch of mathematics that deals with the study of shape, size, and position of an object. Now, this particular thing you must know about geometry is what? Theory. If you don't know theorems in geometry, forget about it. Don't just go there. You won't be able to succeed in what? Geometry. And what is theory? Theory is a statement that can be proven by mathematical or logical argument. A statement that can be proven with mathematical and logical argument. That is what? Theorem. So it's just like, look at how you think about it. If I throw this thing up now, definitely it will fall back to the ground. Now I throw it up again, it will fall back to the ground. I already know that when I throw an object up, it will fall to the ground. So I can take it as a theory that I can tell people, if you throw object up, it will fall to the ground. Whether they believe or not, it's a theory. I have proven it. I have experimented it, even by observation, that if I throw this pen up, it will fall to the ground. I can take it as my theorem. Though there is theory, there is theorem. Theorem is specifically used in mathematics. Theorem. So just have that kind of mindset, so that if I throw this thing up, it will fall to the ground. So the theorems you are going to be taught later, or even some of it will be taught in this particular video. You just need to put those things in your head, just as you put this in your head, that if I throw this thing up, it will fall to the ground. By the time you understand those things, it will help you to solve many problems in geometry. If you don't understand those things, you will not be able to solve problems in geometry. Now, example of and even if maybe tomorrow, maybe I don't have anything to throw up and I meet another person tomorrow, I can boldly tell the person that if you throw an object up, it will fall to the ground. To me, it is now what? A theorem. It is now a theory that if you throw an object up, it will fall to the ground. So with that, I can use that knowledge to solve problem around me. That if I throw something up, it will fall to the ground. So that is how you also gather theorem in geometry to solve geometry problem. You also gather theorem in geometry to solve geometry problem. Usually I do teach my students like this. When we are in the class, we say, I know that if I throw this thing up, it will fall to the ground. Example of one theorem. We have many theorems under geometry. Example of one theorem states that if a transversal cuts through two parallel lines, let's say these two lines are parallel lines. This line is parallel to this line. Now, why is it parallel? It is parallel. You can say it is parallel because if you measure the distance from here to here, though I didn't draw this one to scale anyway, if you measure the distance from here to here, it must be the same with from here to here, it must be the same with from here to here, it must be the same from here to here, it must be the same distance, hence you say it is parallel. Now, if you have that kind of situation, you will notice that there is no way you will draw this line even to the to infinity that these two lines can ever meet. They will not meet because the distance from here to here are always the same. They will never meet. But if there is a slight difference, they will meet. So that is parallel line. Now, the theorem, let's go back to the theory we just want to talk about. The reason why I am going to be talking about, let me say, theory theorem under this video is because I want you to understand how theory connects to geometry, which the importance of theorems in geometry, that is the essence of this video. So that when you are studying this topic, you must put your mind right there in theorem so that you can understand and pass your get your right answers correctly. So now the theorem, the first one we are going to be talking about is that if a transversal cuts through parallel line, whether 2 or 3 or 4 parallel, maybe I have another line here, I have another, it does not matter, provided a transversal, this is a transversal. Any straight line that cuts through parallel line is a transversal. Any straight line that cuts through parallel line is a transversal. This is a parallel line and this is a transversal. It cuts through, it is a straight line, it must be a straight line. Now, it says, the first theory says that if a transversal cuts through 2 parallel lines, the corresponding angles are equal. Now, how do you explain corresponding angle? When you say something correspond, let's take for instance, I clean here. And you say everything here, just look exactly as everything here, correspond with everything here. Okay? Now, you see that this place correspond with this place. That is, if I have this place correspond with this place correspond with this place correspond with this place correspond with this place. Just like children would play with, they will say, maybe if I have somebody at my front now, I will say my left hand looks like your left hand, my right hand looks like your right hand. I am saying, in other words, that my left hand correspond with your left hand, my right hand correspond with your right hand, my right eye correspond with your right eye, my left eye correspond with your left eye. That's the same thing we are talking about here. So this place correspond, this angle, which means if this place is 30 degree, you don't need to solve anything. You already know that here must be 30 degree because this is the theory. If you can go and do it in real life, draw a line. Maybe you have a wood here, a straight plank here, you have another straight plank here, you measure the distance from here to here, you measure the distance from here to here, draw a line, straight line, or put another rod, straight rod, cross it, and measure this angle. If you measure this angle, you will see that it's the same thing with this angle. That's the theory. If you also measure this angle, you will see that it's the same thing with this angle. If you measure this angle, you see that it's the same thing with this angle. That is what corresponding angle. When you hear corresponding angle, that's what it means. It means the part that correspond with each other. So this place, now if I know that this place is let me say 30, and they now ask me find, maybe they now put S here, find S. I will just say S is equal to 30 degree because I know they are corresponding angle. So in maybe you are writing WAEC, you are writing NECO, you are writing any of this exam, you must put the reason there. If you don't put the reason, they will not give you the full mark. You will put the reason to show that you know what you are doing. You write corresponding angle. Okay, so you write corresponding angle in bracket after it. This is angle. If you want to write angle, you write it like this. Or so that is how you write corresponding what? Angle. So the person that is marking your script, you know that yes, you know what you are doing. You know that when you have something like this place is corresponding to this place. That is the first one. Okay, now that's the first theory. It says that when a transversal cuts through parallel line, the corresponding angle are equal. Now another theory again, if I have, maybe I have, let's remove this. Maybe we have A, B, C, Maybe we have A, B, C, D. B, C, D, E, F, G. If you have something like this and they ask you they ask you to find A, find A. Now, the theorems I know in my head will help me to find A. The theorems I already know in my head. I will say, I know, just as I know that if I throw this thing up, it will fall to the ground. I know that angle on a straight line, this is a theorem. Angle on a straight line is equal to 180. Angle on a straight line is equal to 180 is a theorem. So you must put it in your head that whenever you have this, you know, when you complete one cycle is what? 360. That's everything here. 360. So when you cut it into two, this side will be 180, this side will be 180. So this is a straight line. From here to here is 180. This is an angle on a straight line. Here to here is what? 180. That is another theory. So with that, I can solve here. I can solve this angle. So I will now say, okay, I know. Just as I know, I repeat that if I throw this pen up, it will fall to the ground. I know that A plus 30 degree is equal to what? 180 degree. This plus this, they are on this straight line. They are angle on a straight line. Look at it. Angle on a straight line. You know, this angle now plus this angle is equal to 180. That is what I know. I know it. So I will not come here. I will write the reason. If I don't write the reason, there will be dot mark. I will come here and say angle on a straight line is angle on a straight line. So that's the reason. Angle on a straight line is equal to 180. Then I will now look for A, solve it mathematically. I will now say A is equal to 180 minus 30 degree equal to what? 150 degree. So I can boldly now come here and write A is equal to 150 degree. Okay. Now I can use angle on a straight line to solve everything here, but I don't want to use it. I don't want to use that because you can solve this problem in so many ways. You can solve this problem in so many ways, but I just want to introduce another theory. We've talked about two theories now. When a transversal the first one, when a transversal cuts through two parallel lines, the corresponding angles are equal. Angle on a straight line is equal to 180. So let's quickly talk about another theory, which is if a transversal is similar to the first one. If a transversal cuts through parallel lines, the alternate angle are equal. If a alternate angle are equal, that's the theory. If a transversal cuts through parallel line, just this is a transversal. This is a transversal. This is a transversal. If a transversal cuts through two parallel lines, alternate angle are equal. What are alternate angle? I've talked about corresponding angle. Now let's talk about alternate angle. This angle here is alternate to this angle. This angle here is alternate to this angle. So when you hear alternate angle, they are talking about these two angles, that whatever you have here is always the same thing as whatever you have here. Whatever you have here is always the same thing as whatever you have here. That is what alternate angle. So the third theory we have talked about now is saying when a transversal cuts through parallel line, the alternate angles are what? Equal. So you must put it in your mind. You must put it, because this is a question. Now let's assume I want to solve this problem now. This problem I want to solve. Okay, let me look for C now. Let me say in the question they ask me to look for all the angles. Look for this angle, 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 look for this angle. They ask me to look for all this angle. So I will not say, how do I solve this? I know. You see, just as I know that if I throw this thing up, it will fall to the ground. I know that angle on a straight line is equal to 180, which means I will say C plus A. This is a straight line. So everything here is 180, everything here is 180. This is a straight line. So C plus A is equal to 180 degree. I will put it in bracket, angle on a straight line. So I will not say C is what we are looking for. We want to calculate C. I will not say C plus A, which is what? 150. We already have A from the first calculation. 150 equal to 180, because this plus this from the theorem says is equal to 180. I know that one. So from there I cannot calculate C. I will not say C is equal to 180 minus 150 equal to 30 degree. So I cannot clean here now and say this place is equal to 30 degree. C is equal to 30 degree. With that, I have been able to look for what? C. Okay, now I cannot calculate B also. I will say B because this is a straight line. This is a straight line. We have already used this to get this. This is another straight line. We use it to get this. We can still use it to get this one by saying B, which is what we want to calculate now. B plus 30 degree equal to what? 180. What's the reason? Angle on a straight line. You write it completely because of space. Okay. Okay, let me clean. Angle on a straight line. Now, that's the reason you must write it there. It attracts mark. So angle on a straight line. From there, you cannot calculate B, which is equal to 180. You move this one to this side, which will now turn to minus 30 equal to 150 degree. So B is now 150 degree. I can write here B is equal to what? 150 degree. You see how I am able, imagine this was the only angle they gave to me. I have been able to, from this angle, calculate this one, calculate this one, calculate this one, because of the theorems I know in my head. Because of the theorems I know in my head, I have been able to calculate all this one. Now that I have done calculating this one, I know that everything here corresponds to this one. Food is ready. This one, I will not even stress myself calculating this one. Look at this. I will not say D, to calculate D, to number D is equal to 30 degree. That's the answer. I don't need to do all that thing, but I will just write the reason. I will say corresponding angle. I must write this one to show that I know what I am doing, because this place corresponds with this place. So 30, this D is equal to 30 degree. It corresponds to this place. Now I will also come here and say F is equal to 150 degree, because this is F. It corresponds to this angle. We have calculated this one. So since I know here, I already know here. So this one corresponds to this one. Okay. So it will not be what you write the answer, corresponding angle. Corresponding angle. So this one, you can solve it in many ways, but when we now enter other theory, maybe other calculation, you will see how you can apply them. They are very okay. Let's use alternate angle here. Let's use alternate angle. Since I have B here, B is equal to E. B is equal to E. B, I can say E is equal to 150 degree. E is equal to 150 degree. I will write alternate angle. Alternate angle. Now, look at it. I told you that alternate angle is this one is alternate to this one. Whatever that is here is alternate to this one. That's what I said. So since I already know B and I'm looking for E, I will just put E equal to whatever I have here in B to get B. But if I don't want to use alternate angle, I can still use corresponding angle, because this place 150, this place corresponds with this one. So we can have two students in the class. They solve this problem different way. One will use alternate angle, that he knows in his head. The other one will use corresponding angle. It's still the same thing. They have the same answer. They are both correct. So if I want to use, I use alternate angle here because this 150 is alternate to E. I say E is